6.1 Inverse and Relations of Functions. Today you will find and graph inverses of relations and functions. You will also determine if an inverse is a function. To graph an inverse relation or function, switch your x and your y values and then solve for y and then graph. The graph of an inverse will be a reflection of the relation or function across the line y is equal to x. Since the x and the y values are switched, the domain of the relation or function will be the range of its inverse and vice versa. Graph the relation and connect the points. Then graph the inverse. So if our relation is the ordered pairs 0, 2, 1, 5, 5, 6, 8, 9, our inverse, we switch those. And we have 2, 5, 6, 9 as our x values and 0, 1, 5, 8 as our y values. To graph our original relation, we plot the points 0, 2, 1, 5, 5, 6, 8, 9. To graph our inverse function, we plot the points 2, 0, 5, 1, 6, 5, 9, 8. And you can see that these directly reflect over the line y is equal to x, and if we folded our paper in half, they would match up. The domain of our original relation is our x values, and the range of our inverse is our y values. You can see that the domain and range of our relation and our inverse are the same. The range of our regular relation is 2, 5, 6, 9, and the domain of our inverse is 2, 5, 6, 9. So you can see how these are opposite of one another. Functions that undo each other are called inverse functions. When the relation is also a function, you can write the inverse of the function f of x as f to the negative first power of x. This notation does not indicate a reciprocal. You can use the graph of a function f to determine whether the inverse of f is a function by applying the horizontal line test. So if you are looking at the inverse of a function or trying to determine if looking at a function the inverse is also a function, you would ask yourself if it passes the horizontal line test. If any horizontal line passes through more than one point on the graph of your relation, the inverse relation is not a function. To find the inverse, you switch the x and the y value and you solve for y. Replace your f of x with y in the original equation. So in example 2, we're going to find the inverse of the function. We're going to graph the function and its inverse. So to graph our original function, f of x equals 3x plus 6. We have a y-intercept at positive 6, and our slope is up 3 over 1. So we graphed this linear function. We connect our dots. To find the inverse, we switch our x and our y value. We solve for y using inverse operations. The inverse of multiplication is division, so we get 1/3 x minus 2 is equal to y for our inverse. So this is f of negative 1 of x. So our y-intercept is negative 2. Our slope is up 1 over 3. And if we folded our graph along the line y is equal to x, you can see that these two functions would match up. They are both functions because they both pass the horizontal line test. For every x, there is exactly one y. Find the inverse of the function, graph the function and its inverse, determine whether the inverse is a function, and state its domain and range. So when we graph the function, the cubed root of x plus 1, our plus 1 moves our graph 1 to the left. When we're graphing a cubed root function, we go up 1 over 1, up 1 over 3, up 1 over 5, down 1 over 1, down 1 over 3, down 1 over 5. So our cubed root function looks something like this. our actual function is a function. To determine if our inverse is a function, we can use our horizontal line test. And looking at this, there are no two x values for the y values, so it passes the horizontal line test, so our inverse is a function. And to find the function, we switch our x and our y values and solve. So to undo a cubed root, we cube. So x cubed is equal to y plus 1. The inverse of adding 1 is subtracting 1. So we have x cubed minus 1 is equal to y. If you forget how to graph an x cubed function, you can always make a quick t-chart. If you plug negative 1 in, you get negative 1 minus 1 is negative 2. So plot negative 1, negative 2. When you plug 0 in, 0 minus 1 is negative 1. So 0, negative 1. When you plug 1 in, you get 0. When you plug 2 in, 2 cubed is 8 minus 1 is 7. So when you connect your dots and graph your function, you can see that this is the inverse, and it's reflected over the line y is equal to x. Then when you state your domain and range, your domain are your x values, and our x is approaching negative infinity and positive infinity, so we say all real numbers. And our range is looking at our y values. It is also approaching negative and positive infinity, so it is all real numbers. Example number 4, we are going to find the inverse of the function, graph the inverse, determine if it's a function, and state the domain and range. To graph our original function, we have f of x is equal to x squared minus 4. So our square root function is going to move down 4. And then it goes up by the pattern, very similar to our cubic function in a way. You can also plug this into a t-chart to verify. Hopefully you can connect your dots better than me. Switch your x and your y values to solve. Add your 4. X plus 4 equals y squared. To undo a square, use square root. So we have the square root of x plus 4 is equal to y. When we graph our square root function, we know that this plus 4 moves our graph 4 to the left. And then when we graph our square root function, we go over 1 up 1, over 1 up 3. So when we graph the square root, we are actually only graphing half of our original quadratic. Our inverse is a function. If we folded our graph along this line, you could see that this side of our quadratic function would match up with our inverse function. Had I drawn my lines a little nicer. When we talk about the domain of our relation, we want all the x values. Negative 4 is less than or equal to x, so we want all the x values greater than negative 4. When we look at our range, we want to look at our y values, and we want all the y values that are greater than or equal to 0, because our red graph is above 0. So example 5, we're again going to find the inverse of our function, graph both the inverse and our original function that we have right here. Determine whether inverse is a function and state the domain and range. So when we graph the function, the square root of x minus 3, the square root function would originally start at 0, 0. We're going to move 3 units to the right, and then the square root function goes up 1 over 1, up 1 over 3, up 1 over 5. And we have our original function graphed. Remember, you can also use a t-chart if you weren't sure. It does state that we want to graph this for where x is greater than or equal to 3. And we started at 3 and graphed all the points where x is greater than or equal to 3. To find the inverse, we're going to switch our x and our y value. So we get x is equal to the square root of y minus 3. To undo a square, we square both sides. The inverse of minus 3 is plus 3. So we have x squared plus 3 is equal to y. So for our inverse function, if we graph a parabola and we have a 3, that means it moves up 3. And then we go with our normal pattern, up 1 over 1, up 1 over 3. We then connect our dots to form our nice U shape. You can see that if we reflect this over our line y equals x, our two functions would match up. The positive side of our quadratic. When we state our domain, first of all, our inverse does pass the the vertical line test. So it is a function. Our domain are our x values, and we're approaching negative infinity and positive infinity. So we say all real numbers. Our range is our y values. Our lowest y value is positive 3, so we want all the y values greater than or equal to 3.